In this video, we're going to take a quick look at a definition of thermal energy as well as heating curves of water. So let's start out with thermal energy. What is it? Well, essentially it's the total kinetic energy of particles. So if you have same number of particles here, if that was constant and we increase the temperature, we would have a higher kinetic energy or higher average kinetic energy, which means that we have a higher thermal energy. So just kind of keep something to keep in mind in terms of terminology and how they are all related and interchanged with each other. Now, heating curves are really neat, and the heating curve of water is really neat because what you see is you don't get temperature changes when you have state changes. So if you're going solid to liquid or liquid to gas, you actually don't see a temperature change for a certain amount of time. So for example, if we took ice and we started warming it up and we hit our transition temperature at 0 degrees and we start melting, then what you'll see is that there's no temperature change for a certain amount of time, even as we're increasing energy over time. And then once we've fully made that transition into liquid water, we would see the temperature continuously go up. And then once we hit the boiling point, again, during that phase transition, we actually don't see temperature changes for a little bit of time until we're fully into steam, and then we would increase again. And so what's happening here is that the added energy is being used to disrupt the solid lattice and also to overcome any intermolecular forces between the molecules in the liquid. So really neat, really interesting. That is the heating curve of water as well as thermal energy definitions. That's it for this video. We'll see you in the next one.